In this example, we are given that the figure shows a horizontal wire Mn, which is of length L and mass M, is placed in a magnetic field B. And we are also given that the ends of the wire are bent and dipped in two balls containing mercury, which is connected to an external circuit. We can see here a battery and a resistance are there. And if the key is pressed for a short time delta t, due to which a charge Q flows, we are required to find the maximum height above initial level the wire Mn will jump. Now in this situation, for solution we can see, when the switch is pressed for a time delta t, a current flows, and due to this current we can see, by right hand palm rule we can see that the wire will experience a force in upward direction, which is BIL. And as this force is applied for a time delta t, it will experience an impulse in upward direction, which will impart an initial velocity v to the wire. So here we can write, by impulse of magnetic force, we can write the impulse will be BIL delta t, which will be imparting a momentum to the wire Mn. So we can write its initial speed is v. So the momentum imparted will be mv. And in this situation, I delta t is the amount of charge which is passed through the wire, for which we are already given that a total charge Q flows. So here this will give us the value of initial speed imparted to the wire, that is b I delta t we can write as Q. It will be BQL divided by M, that is the initial velocity imparted to the wire. Now in this situation, if this is the initial speed, as soon as it will jerk off, the contact with the mercury in the balls will break and it will decelerate with the gravity, that is with the deceleration g. So in this situation, the maximum height attained by the wire can be simply given by the speed equation. So if the initial speed is v, we can write maximum height attained by wire Mn is, this maximum height we can directly write as v square by 2g. So on substituting the value of this speed, we are getting the result as b square q square l square by 2m square g. That will be the answer to this problem.